Hi everyone, good morning. We'll start. Let me share my screen. So if you notice, I'm writing something like this here with these two hyphens. So which is turning into green color. This is called as comment. Okay, we call it as commenting. If at all you want to add something, add some notes, or if you want to exclude something from execution, you can just put this double hyphens, and even if we execute this along with this one, it won't execute it. Okay, so this is called as single line comment. You can just comment one line. Let's say if you want to comment let's say for example here we have order by. If you don't want to execute the order by, just add double hyphen and execute this line will be commented, it will not be executed. Okay, for one line you can do like this, but if you want to comment multiple lines, for example you want to comment this entire query, what you can do, you can use / star, then it is your starting point of the commenting, and here at the end then use star / from here to here it will be commented. This is multi-line commenting. So even when you execute this, see it will not be, it says it's executed but it will not execute this one, it will ignore it for execution. Okay, that is what is the commenting. We generally use it in the procedures, functions, wherever let's say we write some logic to write a short notes about that logic, we use this. And also something like this also, like here I've written today's date that I'm starting from here. Okay, in the last session we were discussing about CTs and then subqueries and correlated subqueries. I just want to show you some more examples on CTE. In subqueries, we use like this, right? Just to in correlated subquery we use it to connect this with the outer query and fetch the data and something like that. Whereas in in CTE we first write a subquery, so that subquery we use it below in the current execution, right? This result set we use it here in the below statements, right? So we can also use CTE to insert update to a table. Okay, so mostly in interviews and all they'll ask how do you delete duplicates in a table, so that's when also we use CTs. So we have our my database. Let's say in my database, let's say we have employee table, right? Let's see what we have in this. I need to choose. You can also add database name before this. If you are in some other database, let's say for example I'm here in AdventureX 2022. If you're executing this, but this object is in my database, so you can also refer to it like this, my database.dbo.object name. Okay, so here if you notice I have this record as duplicate. Okay, this and both Vijay both. So before that, let me just write a CTE. CTE starts with I call it as, you can give any name to the CTE, EMP CTE as select star from employee. right? Whatever we have here in this query, that we are getting it here. Let's say now I want to update something in the CT. Okay, in this table I can directly update, but based on some condition, if you want to update, so you can do like this. I'll just copy paste this below. Instead of select, let's say I type update EMPCT set. Let's say I want to update the salary of the employee Praveen to 2000, for example. Set salary equals to 2000, where name equals to Praveen. So even though I am updating, I'm writing a update statement on CT. So now it says 2 rows affected. Now if I execute this query, if I see in the table, now the values are updated to here. This one we had 1000, others we had 2000, right? It is updated. Okay, let me change it again to 3000. Execute. 2 rows affected. If I execute, see now only this and this is changed to 3000. Okay, now so let's say there are duplicates here, right? Here is duplicate, this one is duplicate, and even this Vijay, this record and this record. So these two are duplicate records, correct? So if I want to delete duplicate records, how do we delete? Before we do that, there is something called ranking functions. We'll understand them first. Okay, then we'll see how we can delete duplicate records using those ranking functions. We have 4 ranking functions: row number, rank, dense rank, and entile. Okay, I'll just write a query with CT. You can just give a name as CT itself, as let us say I'll select from select ID, name, and salary, from okay. Here DBO stands for database object. That is a schema actually. Schema, it's a default schema. DBO is a default schema. So we can also create our own schema. Schema as in it's just a kind of bucketing to put the related objects inside that. Okay. For example, if you go to the AdventureWorks 2022, if I expand the tables, here you notice we have DBO. Along with that, we have human resources. Then we have department, employee, and other tables. Then we have persons, address, and all that, person detail, information. Then we have production dot some table names. That means anything related to production are put inside the schema. Then we have purchasing. Anything related to purchasing, that is put under this purchasing schema. And sales, anything related to sales is put under the sales schema. Okay, it's just a kind of bucketing to organize your tables. If you just see anything you see under this sales schema, that is related to sales. Anything you see under this production schema, that is related to production, like that. And DBO is the default schema. Okay, even if you don't create any schema, even if you don't add your table inside the schema, then SQL Server will automatically take it in database object schema. Okay, we'll see later how do we create the schema and all that. It's simple. You just need to create simple, create schema, and whenever you create a table, you just attach that schema name to it. That's all. Okay, anyways, now ranking numbers, ranking functions, row number over. I'll just explain this after typing it. Partition by, let's say, ID, order by ID. I call it as row number. From employee. Okay, so if I just execute this and below this I can write select star from city. Let's say I'll first comment this row number, then execute this. So here we are getting the data present in the employee table. If I uncomment this and then execute it, see here, can you notice the result set? Employee ID, employee name, salary. These three columns I am pulling, and this row number, what it does is it gives a row number to your column. Okay, for example, I am using this partition by, let me delete that. Let me show you now. See here, for each and every row, it assigns a row number. So row number will assign a row number to your rows. Here I have 5 rows, so it is assigning 1 to 5. If you have 100 rows, it will assign rows starting from 1 to 100. Now we have something called over clause. What this will do is, in over clause there are two things. One is partition by, say this one, partition by, then order by. So partition by is not mandatory, it's optional, whereas order by is mandatory. You need to specify how do you want to add these numbers. You have to order by, right? You have to sort these records in ascending or descending order, then only you can add the numbers. So this order by will sort your data by ID column. That's what we have given here. And by default for order by, it will be ascending by default. If you want to do it in descending, you can just give like this, descending. Just now notice for Praveen, I have 100, 100 and 1, 2. Since I've given it as descending order, now Praveen will become row number 3 and 4 and 5. You know? Are you all getting this? Okay. row number is just a function, like how we have sum, minimum, maximum, average. Like that, row number is also a function, but it takes this extra clause called over. In this, we define how to order the records and number them. Okay, it will order based on the ID column. If I give, for example, Praveen instead of ID, let's say instead of ID, if I give name in the descending order, so it will order these records in the descending order of the name, and accordingly it will number them. If I execute it, see here, in the descending order of the name column, it is ordered, accordingly numbers are given. Okay, I'll change it to ID. Now what happens, there is one more clause called partition by, right? If I add partition by, I have to add column partition by ID. What this will do is, it will, of course, yes, I'll give it as ascending only. This will partition this data based on this column, ID column. That means if you have the same number, it will consider this as one partition and it will sort the values accordingly, and then the row number will be added. Means here, let's say I have 101 and 101. So this will consider it as one group, one partition. Okay, and within this partition, numbering is given. Within the partition, the ordering is done. Okay, let's say if 100 is there, it will partition this. Within this, the numbering is given. That means in this, number won't be continuous. Within this partition, the numbering will be given. So let's see how this will work. Just notice these numbers. See here, based on the ID column, it is partitioned because these two are same numbers. It has partitioned it and it has given number 1 and 2 within this. Again, there is one more number which has two records. It has partitioned by this and it has given numbers 1 and 2 within this. Similarly, the third one. Okay, so let me duplicate this again. I'll add so I've inserted the same number of records to the table again. Now what has happened? For Praveen, I have 4 records, right? These 4 records. Let's see how this will work now. You know, partition by ID. So the IDs with the same values is partitioned like this, and then the row number is given within that, 1 to 4, and again the partitioning is done on the next value, same value, then the numbering is given within that. Again this one, and the numbering is given within that. So this is the row number, right? Now there is rank also, right? Let's see how ranking will work. So rank is also same thing. Rank, syntax is same. Then it takes over clause, partition by ID, order by ID. call it as rank RNK. Okay, let's see what this will give. Can you notice it is giving the same number? Partition by ID. So it is partitioned by this and order by ID. So it has partitioned it as one bucket, this one, and after that the ID is same. Correct. So it is giving same ranking. It is 100 only. So it is giving same record. For example, if I had used order by, let's say partition by instead of order, let's say I'll use partition by salary. Let's see how this will work. Okay, salary, right? Yeah. See here, I have partitioned it by salary. So till here, it will partition it. One partition. Within that, based on the ID, it has to give the numbers. So from here to here. So means from here to here, it is the same ID. That's why it is giving rank as 1 to 4. It means one only till the fourth record. But within this bucketing, there is new entry coming in here. For that, it is giving 5 and 5. That means till here, it is 1. After that, what would be the next rank? 5. How do we rank? So based on the marks for the student, how do we rank? Let's say there are 10 students. Top 4 have got the same marks. Let's say out of 100, top 4 students have got 100 marks. Then 5th student has got 99 marks. We call the top 4 students as the rank 1 only, right? All the top 4 are ranked as are marked as rank 1 only, and the guy who has got 99 marks is ranked as, he's not ranked as 2, he's 5th rank, because above him there are already 4 students who are in the first rank. He's not the second rank, right? Are you getting what I'm trying to say? Yes, no? Okay, and again, from starting from 3000, there is one more salary which is grouped by this, and in this we have the same ID, that's why it is giving the same rank, right? And to this there is one more called dense rank. This is also same over partition by, I'll use salary, then order by ID. I call this as dense rank. Okay, if I execute this, see here. Here in the rank, after 4th, it is after 4 records, next one is 5 and 6. Whereas here in the dense rank, it is 2, 2. In the dense rank, what happens? In the rank, what happens? If there are 4 records with the same rank, it will skip those numbers and it will start with the 5th rank. Because there are already 4 ranks above, it will start with the 5th. Whereas in the dense rank, it will not skip the ranks. It will start from the immediate ranking. Even though there are 4 ranking values available above, it will start from the 1 is there, it will start from the 2. In the rank, it will skip the ranks, whereas in the dense rank, it won't skip it. Okay. Now, there is one more thing called n tile. This is little different. Let's say I enter 3 here. Okay. But over clause is same. I'll just copy paste the same thing. See now what is happening? N tile, it will just split your data into the number of buckets that you specify inside it. So I have specified 3, right? So what it does first, it will do partition by salary. So when it does partition by salary, these are all having the same salary. So that's why it will create one group with these records. Within this, I've given 3 here as an input for the n tile function. So it will split these records into 3 buckets. Since there are 6 records, it has added 2, 2 and 2, 6 records. In the below partition here, there are 4 records, but it has to still split it into 3 buckets. So what it has done? First 2 records, it has assigned 1 and 1. Then the 2 and 3. What it will do? It will do number of records. It will take the number of records in that partition and then it will split it into number of buckets that you specify here. Let's say I specify 2, for example, 2 buckets. Now see here what happens. There are 3 buckets now. Now see, only 1 and 2. Here also 1, 1 and 2, 2. 2 buckets only. So this is how these ranking functions will work. Okay, so if you use partition by, it will group based on this column and then add the ranking values or the numbers based on whether it is row number, rank, dense rank or n tile. If you don't use partition, it will just sort based on the, because order by is mandatory. So it will sort by whatever column you specify here and accordingly the numbering will be given. Right? No, in the rank function, what we have written, we have done the partition by salary, right? So it will partition based on the salary. So this is one partition because till this record, it is the same salary, 2000. So it is partitioned it as one group. So within this group, based on the order by column, let's say within this group, it will order by date. It will sort by, it will sort by the ID. Okay, then it will give the rank. So what has happened? This is one group. Within this, till record 1 till record 4, it is the same ID. So that's why it is given the same rank. After this, the ID is changing, and then it will give 5 and 6, 5 and 5, because it is having the same number. Now, why again 1 is coming? Because of the partition by. Then again it will partition this salary as one group because the salary is different. Within this salary, then it will sort the data by this ID column. Since there is same ID, then it is giving 111 only. Right? Okay. So just to reiterate, it is little tricky to understand in the initial time, so you need to just spend some time practicing this with a different data set, then only you'll understand. But let me just tell you about this again. Rank number, it will just give you the row number for each and every row. Okay, but if you do not use the partition by, for example, as I said, partition by is not mandatory. I'll add here. Is optional. Okay, if you do not add the partition by, let's say I'll remove this for now. If I execute this, just notice the row number. This one. See here it is given numbering to all the rows. I have 10 rows starting from 1 till 10. It has given 1, 2, 3, 4, 5, 6 through 10. Okay, if I use partition by, now what happens? It will group the values by ID. It will group this as one. It will group these rows as one bucket, this as other bucket, and this as another bucket based on the IDs. Like how group by will work, same way partition by will also work. And within this group, it will assign the numbers. Okay, row number. Just check this. I'll comment this for now. You can also comment by clicking on this icon above. See, within this group, it has assigned the number 1, 2, 3, 4, and then it is grouping this as one bucket, and it has assigned the values 1, 2, 3, 4. And this is another number, that's why it is partitioned again, grouped again, and it has two records, so that's why 1 and 2. Clear? This is how row number will work. Now let me comment row number, uncomment rank. Let's see how this will work. See here in the ranking, what happens? I'll remove partition by from here also. Okay, I'll just use order by. When I do order by ID, what it does, it will group based on the ID, which is having the same ID, it will group into one bucket. Since the ID is same, it is giving one only, 1 rank. If somebody scores 100 out of 100, like let's say there are 4 people who have scored 100 out of 100, we give them first rank only, right? Everybody. So that's why it is first rank. Then second bucket, they are all 5th rank. The same example I'll take again. Out of 10 students in your class, 4 students have ranked out of 100 marks. So you will call them as first rank. And next 4 students have scored 99 marks. You give them 5th rank, all of them 5th rank, right? Because there are already 4 people above with the first rank, right? And then the remaining 2, there are 4 positions gone, and from here to here there are another 4 positions gone. Then they will be ranked as 9th position if they've scored 98, for example. That's how this will work. Okay, so if I use partition by, for example, partition by salary I'm using. Now what happens? By salary, it will partition it. This will be one group, and this record set will be one group. So within this group, the ranking will be given. So for this it won't be changed because we have the same ID, but for this it will change because within this group we have two IDs. For ID 101 you will have one rank, and for ID 103 you will have another rank. Let's see how it will work. See, now for 100 there is no change, it is one rank only. But for this result set, record set, this salary is same, whereas the ID is changing. So till 101 same ID, it is ranked as 1, and after that it is ranked as 5. That means it will skip these ranks. There are 4 ranks already above given, so it will skip those positions and it will start from the 5, right? Now let me comment this, then okay, I'll keep rank and dense rank so that you can compare it better. Okay, what is happening here? In case of rank, it has skipped these positions and it has started with 5 and 6. Whereas dense rank, it won't skip the positions. It will start from its next ranking. That is the difference between rank and dense rank. While ranking, rank will skip the positions, these 4 positions start from 5. If at all you had above 5 ones, then it will start from 6, like that. It will skip the ranking position. Dense rank will not skip, it will start from the immediate number. That is a dense rank. Whereas entile, if I execute entile, here also let's say I'll remove the partition by first. Just use order by. Now what happens? It is ordering by this column, but it is just splitting the entire data set into 2 buckets. So 10 records, the first 5 records will be given as number 1, and next 5 records will be given number as 2. So if I add 3, that means it will split these records into 3 buckets. First 4 as 1, then 2, and then 3. Right? If I give 5, for example, it will split them into 5 buckets like this. Okay, if I use partition by to it, and 2 again. So if I give partition by, what happens? It will group based on the salary. So it will group these records into one data set, and within that, based on the ID, it will split it. I have given 2, it will become 1 2 1 2. This will become 1 1 and 2 2, and this will become 1 1 1 and 2 2 2. Let's see. See here, this become 1 1 2 2, and this has become 1 1 1 2 2 2 because it is splitting it into 2 buckets. Okay, so this is how ranking functions will work. If I execute all together, this is how it will work, and you can use with them within the CTE. Now, how can we use these ranking functions to delete duplicates in this table? So now we know that in the employee table we have duplicate records. How do we delete duplicates? We can use row number. We can use row number and assign numbers to these rows. Okay, based on, let's say what I do, I use partition by ID and then order by ID, then give the numbers. So now let's see what happens. I'll just copy this CT, paste it below. Here I'll remove these ones, the rank and rank I don't need. You can use them also, but I'll just use this one. So now if I execute, this will give me, I'm partitioning it by ID, so that means this will become one group and this will become one group, this will become one group. So within this I have assigned the row number 1 to 4 and this is 1 to 4. Now what I do, outside the CT, instead of select, I write delete from CT, where now whatever columns I have created here, let's say row number also I've created, I have access to this outside of this CT if I execute this together. Okay, now I use this new row number column to identify my unique record. So for me, I need only this, right? Wherever I see row number as 1, only this I need. If I take this and delete remaining, I'll get the unique record. So I add a where condition where row number greater than 1. So now what happens? Except 1, anything which is greater than 1, it will delete. In this case, it will delete these 3 records. In this case, it will delete these 3 records. In this case, it will delete this record, thereby leaving only the unique records. So I execute this. So it says 7 rows affected. Now if I execute this, now I have only a unique records left in my table. Clear? Any questions still here? And this is the most commonly asked question in the interview. How do you identify duplicates in a table and how do you delete them? Any questions, or we can proceed ahead? Okay, let's move ahead. Since we were talking about schema, let's look into schema. What are schemas? Right. What is schema? As I said, basically just to group the objects in my database, I use schemas. Okay, let's say human resource is there. If I want to organize my tables or the objects which are related to human resource, I create the schema, and anything that I create later related to human resource will be added inside the human resource schema, right? Be it your table, functions, procedures, views, anything. Okay, and how do we create a schema? Let's say I'll go to my database. Here, creating schema is simple. Create schema, then type a name, let's say my schema, for example. Within the, I use my database. If I execute this my database, that means it will change your database to my database. Then I create schema as my schema. Execute this. It executed, but under the my database, you don't see it directly after creating it. It is there, but you don't see it here. When will you see it? when you create an object, let's say I create a table, create table. Earlier, how are we creating table? Create table, let's say employee 1, ID as int, name varchar, $100. Like this. We used to one is created under the DBO schema. That means SQL Server will automatically add it in the default schema, which is DBO schema. Now, if I add my schema to it, while creating this table, if I add my schema dot employee, if I execute this, it has created table again. Now, if I refresh the data tables, so now employee table is created under my schema. Anything, any other table, future tables that you want to add within this my schema, when creating the table, you need to specify the schema name dot table name, then it will be added into this schema. This is the schema. Simple, right? And now when you're using it also, let's say when you're using it also, let's say select star from, if you just do employee, if you just do employee 1, it will be pulling data from this table. If you want to pull data from here, then you need to specify my schema dot employee only. Then only it will take data from this one. Okay, for example, let's say I delete this table employee.1 from DBO. Delete it. Deleting as in dropping it. Okay, I've deleted the DBO.employee1. If I execute this, it won't work. It says invalid object name. Even though you have it here as employee name, but you need to specify this with my schema employee. So now this will work. We don't have any data, that's why it's not showing, but now it will work. So if you use a schema, then while accessing the table also, you need to specify the schema name. That's about the schema. Then let's start with joins. It is important. Then we'll look into functions and procedures. What are joins? Why do we use them? How many of you know about joins? Okay, joins are used to connect multiple tables and pull the data from the different tables. Join used to combine data vertically, not horizontally. Connect with multiple tables, yes. Pull info from related tables, correct. Connect multiple tables and fetch the desired records, correct. To join multiple tables, okay. Basically, joins are used to connect multiple tables and pull the data from them. Okay, and how do we connect? We connect based on a common column. There should be a common column between two tables, right? Then only you can pull the data. Now let's go back to our AdventureWorks database. You can just change the database name from here, but I'm just using this use database statement because when I share this code with you, you know that I'm executing this in different database. Okay, now I'm in the AdventureWorks database. Basically, there are how many joins we have? How many joins we have? Cross, inner, outer, natural, self. Okay, what are the joins that we have? 4, 5. We have inner join, outer join, cross join. So we basically have 3 main joins: inner join, outer join, and cross join. Okay, so in outer join we have 3 more. Left outer join, right outer join, and full outer join. Right? Cross join is there, and in the inner join is only one join we have. But in the inner join, if you either inner join or outer join, if you use the same join, it's okay. If you use the same table to join it with itself, it is called as self join. Okay, self join. This is not a separate join. If you join the same table with itself, then it is called as join, a self join. Okay, it is not a separate join. Okay, so basically these joins only: inner join, outer join, cross join. So in the outer join we have left outer join, right outer join, and full outer join. Now in inner join, what happens? Let's say we have 2 tables, table A and table B. Inner join, only the matching records from both the tables will be fetched. Whereas in the outer join, left outer join, matching record from both the tables as well as all the records from the left table. From the outer join, matching record from both the tables and all the records from the right table. Whereas from the full outer join, matching records from both the table and all the records from both the tables. Cross join, it will give you the product of records from both the tables. It will multiply each record with all the records of the other table. So if you have 2 records in both, how many records you'll get? 2 into 2, 4 records you'll get. If you have 2 records in one table, 3 records in another table, 2 into 3, you'll get 6 records, like that. Okay. Okay, just give me a moment. I'm trying to connect my writing pad to show you how this joins will work. There is some issue. Okay, the writing pad is not working still, so I'm just showing it here from this which I already have. So here I have 2 tables, table A, table B. Okay, in table A we have 1, 2, 3, 4, and 7. In table B we have 1, 2, 5, 6, 8. That's records. So if I write the tables like this as a circle, and within that if I write what are the values I have in table A, if you see 1, 2, 3, 4, 7, and in table B I have 1, 2, 5, 6, 8. Okay, when I intersect these tables, these 2 tables, in case of inner join, I'll get only the common values between table A and table B. In case of left outer join, I'll get only the common columns as well as all the common records as well as all the records from the left table. What are the common values here? 1 and 2. 1 is there here, 1 is there here, 1 is there here, 1 is there here. Common records I get. Also, since it's the left outer join, I'll get all the records from the left table, which are 3, 4 and 7. I don't get these records. Okay. In case of right outer join, I'll get common records, which are 1, 2, and all the records from the table B, right table, which is 5, 6, 8. In case of full outer join, I'll get common columns, all the columns from the common rows, all the rows from the left table, and all the rows from the right table. Okay. And in case of cross join, we'll get a Cartesian product of records. That means each record from the left table will match with each record from the right table. That means you'll get 1, 1, 1, 2, 1, 5, 1, 6, 1, 8. Then you'll get 2, 1, 2, 2, 2, 5, 2, 6, 2, 8. 3, 1, 3, 2, 3, 5, 3, 6, and 3, 8, and so on. That's why the number of records you'll get from the cross join is this number of records from the left table multiplied by number of records in the right table. This is how the joins will work. Okay. Let's see this here. Let me use my database. I'll create these two tables. Create table A. I'll just have one column as ID. Create table B. ID int. Okay. So I'll insert records to this. Insert into table A. ID values 1, 2, 3, and then 4 and 7. One, 2, 3, 4, 7. Okay, whereas here one, 2, 5, 6, 8. Execute this. Okay, sorry, I did not create this table, right? I just wrote a statement. Until and unless you execute this, it won't be added in your database, right? 5 rows affected. Table created. 5 rows affected. Now if I do select star from table A, select star from table B, execute this. Sorry, I inserted it to same table again. Sorry, I'll have to change the table name. I'll drop these tables. Drop table A. I'll have to only drop table A. Anyway, for table B, I have not inserted. I'll recreate it again. Okay, now table A, I have these records, and table B, I have these records. If I run these together, I have these records, right? Now if I do select star from table A, then I use inner join table B. Here in joins, importantly, we should use a on condition, okay, on which we are joining these two tables. So here I use ID column table A, ID column of table A equals to ID column of table B. So here you can specify table name and the column name, or you can also alias the tables. Like I call this table as A, for example, in this table as B, you can just use A.id and B.id. So whatever alias you have given, you can use it to refer to that tables column, especially when you have same column names. So it will find it as ambiguous. SQL Server won't understand which table this column is coming from. Okay, that's why you need to specify the table name, or if you alias, you need to use the alias name. So this is inner join. If I execute this inner join along with this, what is happening? From the left table I have 1 2 3 4 7, and in the right table I have 1 2 5 6 7. What is common here? 1 and 2 and 1 and 2 in this. I'm only getting those records. Since I'm using star, it will take column from table A and table B both. Only the common records I'm getting here. If I copy paste this, instead of inner join, I change this to left outer join. I'll comment this. Now what happens? Only matching records and all the records from the left table, whereas since there is no match for these records in the right table, I'll get null values from the right table. And if you use where clause here, where b.id is not null, then you will not get these null records also. It will be similar to your inner join only if you use this where condition. Okay. Now, so this outer keyword, it's not mandatory, it is optional. Okay. Outer keyword is optional. Even if I remove this outer, we'll just write left join only. We don't write left outer join and all. It'll still work. See here. So even though it is left outer join, the outer keyword is not mandatory, it is optional. Similarly, I copy this, paste it below, I change it to right outer join, and I comment this. In the right outer join, what happens? You'll get matching records and all the records from the right table, even though there is no match in the left table. And if you use where clause here also, then you'll get only matching records like a inner join. Right? Here also outer keyword is not mandatory. So we generally don't write outer, we just write right join, left join. It's understood that it's outer join. Then if I do full join, along with this, so now I get matching records, all the records from the left table and all the records from the right table. Now here, wherever there is no match from the right table, then you will get null records, null value, and wherever there is no match in the left table, you will get null there. right? This is how full outer join will work. If I use cross join, for the cross join, on condition is not required. On clause is not required, because anyway it just does a multiplication from this to this, this to this. It will match with each and every record. So if you execute this, see here, how many records we have? 5 records in this and 5 records in this. 5 into 5, 25 records it will give. Like it will match this one with all the records of this 1, 2, 1, 3, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 7 from here. And if you take 2, then it will match 2, 1, 2, 2, 2, 3, 2, 4, 2, 7. Then we have 5 here, then 5, 1, 5, 2, 5, 3, 5, 4, 5, 7, like that. It'll just match it with each and every record. And even if you take this one 1, 1, 1, 2, 1, 5, 1, 6, 1, 8, you'll see 1, 1, 1, 2, 1, 5, 1, 6, 1, 8, like this. It'll match with each and every record. This is the cross join. Okay, so you should be careful when you're using the cross join. If you have thousands of records in both the tables, and if you use cross join, it will generate millions of records. Okay, you have to be careful over there. So these we will see with real examples later, like from the database adventure works that we have. But for now, any questions on this? Clear how these joins will work? Basically, how many joins we have? 3 main joins: inner join, outer join, and cross join. In the outer join, we have left outer join, right outer join, full outer join. So it making it 1, 4, and 5 joins. And we have self join. Self join is you take any join. If you join the same table with itself, then it is called a self join. Okay, I have a question for you. Let's say I have, okay, I'll open it in Excel. Let's say this is my table A. This is my table B. I have 1 and 1. In this also I have 1 and 1. And this is also, sometimes people will ask in the interview. Okay, now say I have inner join, left outer, right outer, full outer, then cross. We'll leave cross for now. We'll use only these 4. This is case 1. Now with this, tell me how many records we'll get for inner join, how many records we'll get for outer join, and how many records for left outer, right outer, and full outer, having this table. And the column name here is ID, sorry, ID. Here also it is ID. This is table A. This is table B. Okay. Suhail says all outputs will be same, 4 rows. Okay. What about others? Inner join 2. Okay. What about left outer join, right outer join, and full outer join? Like how many records we'll get? If you see here in the query when you execute, see here in table A and table B with this records, 5 records in each, right? So when I execute inner join, I'm getting only 2 records because only 2 are matching. When I execute left outer join, I'm getting 5 records. When I execute right outer join, I'm getting 5 records. When I execute full outer join, I'm getting 8 records. So this is what I'm asking, how many records we will get for each of these in this scenario. Lakshmi says inner join 1, outer join 2, left outer join 2, right outer join 2, and full outer join 2. Okay, what about others? What do you think? Four records because each match by twice. Okay. Inner also 2. Okay. Now tell me for all the joins, not only for inner. I'm asking for all of these, all these 4 joins. All 2, all joins 2, all 2, each match all. Sunny Kumar says inner 2, left 2, right 2, and full also 2. Revati 1, 2, 2, 4. 1, 2, 2, 4. Okay. For your surprise, let me just let's execute this here in SQL directly. Let's see. I'll just copy this. Table A, I just have 1 and 1. Table B. Okay. I have, oh sorry, 1 and 2 inserted. Sorry. I'll drop and recreate again. You can drop multiple tables like this in single statement. Okay, I have like this 1 and 1, right? So if I use inner join, okay, lot of many different answers, right? 1 record, 2 record, 1 1 2 2 record, 1 2 2 2 record, something like that. So for inner join, we'll get 4 records. How? Interesting, right? So for inner join, we get 4 records. For left outer join, let's execute that also. And also for inner join, the inner keyword is also optional. Okay, if you just write join, then it considers it as inner join only. I'll just write here for inner join. Inner keyword is optional. If you just write join, it understands it as join only. Okay, so left join. How many records for left join? 4 records. How many records for right join? 4 records again. For full join, also 4 records. So that means with this number of records, with these values, you will get 4 records for all of the joins. Right? Why this is happening? Because on the on class, we match on this column, right? So first it will take this column from the left table and this value A, then it will see if there is a match in table B. So this one will match with this record, and the same record it will check for other records also in this table if there are any match. So this one record will get 2 records. So 2 records I got. Similarly, it will check for the second record. This will check with this first record, it is matching, it will return 1, and again this will check with this. It will find another match, that's why it will give you 4 records. Correct? Same thing, even for the left outer join, it has to first, before getting all the records from the left table, it will first give you the matching records. So it will match this record with all the records of this. So this will give 2 records, this will give 2 records. So 4 records. Then we don't have any extra records in the left table, that's why only 4 it is returned. And for the right outer join, same thing, all the matching records will give you 4 records. And in the right table, we don't have any other extra records, so we get 4 records. And full outer join also, same thing, 4. Clear? It will work like 2 loops. Okay, so this table will work as outer loop. Okay, let's say if you know any programming language where you have the outer loop, outer for loop, inner for loop, so it will take this, let's say this is your outer loop, this is your inner loop. Okay, so in the outer loop it has value 1 and 1, so it will just take first outer value, and here also we have 1 and 1. It will just take this outer value and check this with this one, it will return 1 record, and then again it will come back to the outer loop. In the inner loop it will check for the other record, so it will return 2 records. Then the loop will come back, then it will take the second record, then it will match with this one, and again it will match with this one, it will give 2 records. So total it will give you 4 records. Okay, now let's change it a little bit. Let's say I have one null value here. Now tell me, this is case 2. How many records we'll get for each of these? Okay, left outer 5, full outer 5, inner 4, 6, 4, 5, 4, 6. Okay. Okay. For inner join, of course, we'll get 4. For left outer join, 4 plus there is 1 extra, we get 5. Right outer join, there are no extra records in the right table, so only 4. Full outer join? 5. Correct? Let's check this. Let's insert okay, insert values. Okay, now I have like this, right? If I execute inner join, 4 records. If I execute left join, 5 records. This is actually null record from the left table, and right table there is no match. That's why you'll get 5 record. The null there also. Then right outer join, 4 records. Full outer join, 5 records. Correct? Now let's make it a little interesting. So I'll add one more null here. Now tell me how many records we'll get. Case 3. How many records we'll get for inner, left outer join, right outer join, and full outer join? Okay, 6 for all. 4, 5, 5, 5. 6, 5, 6, 6. 4, 5, 6, 6. Okay. I'll leave it to you. Just create this table, add values like this, and see it yourselves. Okay, and let me know tomorrow how many records we get for each of these joins. Right? So any questions till here on ranking functions and joins? Okay, fine then. So in tomorrow's session, we'll see some examples from AdventureWorks database that we have, how the joins will work, and then we'll see functions and procedures. Okay, thank you so much for joining in. See you tomorrow.